This is Food Chemistry Unit 2. We're still in Chapter 5, Energy Flow and Phase Changes. So I'm going to go back and forth with this diagram. This is a heating curve, and you can tell there's different phase changes listed on here. So as I describe them, I'll be referencing this curve. So solid to liquid, this is known as fusion or melting. Energy is added. Liquid to solid, right? The reverse, this is known as crystallization or freezing. Energy is removed. The latent heat of fusion is the energy needed to melt or freeze a substance. So this is occurring right here. So you can see here's freezing, melting, and there's this number involved, right? This 334, that's the energy needed to freeze or melt. So if you notice this line is flat, this is the phase change. So if you notice, there's no temperature change right here. It is the same for freezing or melting. And on the Celsius scale, which is what we use in our class, it would be 0 degrees. Now, liquid to gas, this is known as evaporation or boiling. Energy is added. Gas to liquid, known as condensation or liquefaction, energy is removed. The latent heat of vaporization is the energy needed to evaporate or condense a substance. So this is occurring right here. So here's condensing, here's evaporating. These arrows are telling you the same thing down here if energy is going in or out. And then there's this number above it. That's the energy value. Notice this line is straight or flat. There is no temperature change. So condensation or evaporation or like boiling, right? It's 100 degrees Celsius for water. So that should look familiar, but notice that this is not changing. So that line that I've been referencing, that is known as a phase change. Temperature remains constant. The molecules need to organize themselves into a new pattern or phase. Sometimes the liquid phase can be skipped under certain temperature and pressure conditions. This would be a gas to a solid without passing through the liquid phase is known as deposition. This would be frost on your window in the winter. Water vapor in the air vapor is a gas, right? It's changed directly to that solid ice on your window. That would be deposition. Frost in a freezer indicates that that freezer is cold enough to freeze ice cream, and energy is released during this process. Solid to a gas without passing through the liquid phase is sublimation. This would be dry ice or solid carbon dioxide. So the solid right here would change to a gas without turning into a liquid, and that solid is not something you'd want to touch. It actually would burn you. This process is used for freeze-dried products like instant coffee or instant tea, right? You can see like the dry strawberries here. That's often added in cereal. Energy is added during sublimation. Factors that affect the rates of reaction in food preparation. So the rates of reaction, right? What can affect this? Well, temperature of the reactants. As temperature increases, the movement of molecules increases. You have more collisions. The speed of cooking is directly related to temperature. So if you roast, like this turkey right here, it cooks faster in an oven than a slow cooker, hence the name slow cooker. So a slow cooker uses a lower temperature for a longer period of time. So often this is like on a surface, right? Instead of turning on an oven, people will put it in here and just let it go for longer periods of time. So, and it often doesn't heat up the room as much as an oven would. So that's why people want to use it. It's really just your preference, but the oven would take less time. There's a higher temperature than your slow cooker. The amount of surface area. The greater the surface area, the faster the reaction occurs. So a 4-pound roast right here takes 7 to 8 hours to cook in that slow cooker that I just mentioned. But if you cut it into cubes, the same roast would take 3 to 5 hours, right? So it's a lot less time because you increase the surface area with the smaller pieces. Thickness of food. The farther the center of a food is from the surface, the longer it's going to take to cook. If you cut the food, it increases the surface area and decreases that distance from the center. Microwave speed food because they penetrate 5 to 7.5 centimeters deep into the food. Cooking can begin below the surface quicker, and you really have to be careful with your meats that have to be cooked all the way through. So that's why a good thermometer would help with this. But again, the less thick it is, the faster it's going to cook.